What's his bucket on the screen?
Okay.
He has fire powers. What's his?
That's like
Spend, right? Yeah.
Okay. With substitution, the more practice you get, the better. Okay. You need to be able to recognize when substitution is going to work and when it is not going to work. So these are the examples that we are going to do today.
It won't work on the first one.
Now, I have also thrown in times where we may need, oh, maybe not. Okay, these are the examples we're going to do first, and then we're going to throw in some natural log and e to the x examples. Okay? So, who needs some exercise?
I always need exercise.
Come up here and choose one. I think if you click that little, see how each one of them? Click this right now.
Whoa.
Thank you.
Oh, that's it.
Yeah.
I should. No, it's just the hardest one.
Maybe this is the hardest
No,
one.
this one's really easy.
Okay, then what should we
It
do?
really is. Well, first you have to find what the inner function would be, and that would be cotangent theta.
I have a question for you.
Okay. I probably have.
Do we have a composition of a function times another function?
No.
No. This is not in the form of that chain rule because there's only a composition. Right? If we let u be, because you were going to say let u be cotangent, right?
Yeah.
If we let u be cotangent, what would du be?
Secant squared. Or no, cosecant squared. Negative cosecant squared.
There you go.
Will that work?
No.
We don't have this.
Yeah.
So we cannot do this substitution because we don't have negative cosecant squared theta to replace. So, instead, anybody have an idea?
We can split it up. Is it cotangent theta times cotangent theta?
Is that going to help?
No. But
We can't
it
split
was
an
like,
integral up by,
Can we split cotangent into something?
we can do something with cotangent squared.
Can we turn it over to some square?
Probably that's a little worse.
And is this going to be helpful?
Yes.
Yes.
That's what I said.
How?
Because you can make the bottom, then you can do sub that
Bottom B.
sine.
Cosine and cosine squared.
It's not going to work, is it?
It's sine squared though.
And then we separate it, the cosine over sine times cosine over sine.
That's negative cosine.
And then,
No, it's not.
because it's the
Derivatives.
Oh.
Okay? If we let u be sine, our du is only cosine d theta. I have cosine squared d theta.
You do sine squared then.
No,
No, because sine squared isn't inside anything.
You did big one.
I'm sorry, it looks easy. That's what it is.
It's
You
true.
divided both by sine.
Oh, it's that one that I don't remember.
Okay.
So you add 1.
Cotangent squared can be rewritten as what?
Cosecant squared minus 1.
Oh.
Oh. I was getting there.
Can we integrate cosecant squared?
Yes.
It's tangent.
Cotangent.
No,
Negative.
it's not.
What is it?
Negative cotangent.
-1?
Minus beta.
Hey, we need to recognize when substitution's going to work and when substitution's not going to work. Okay? Anytime you can rewrite your integral, you probably should. Alright? You guys are getting stuck in this UDU mode. You still need to be able to recognize when you can do a simple rewrite and be just fine. Okay? That's why I have these examples up.
Okay,
Alright, questions on this?
we did it.
Science.
Pick another one. Who wants some exercise?
Me. I ain't even gonna look at them, I just want this one.
What do you have to look at?
Nope, I looked at the little square.
Okay. Ideas.
We can do
Rewrite it
substitution.
first.
We can do substitution.
Aaron thinks we can do substitution.
One
Jared thinks
plus-
we
I
should
just want to
rewrite.
rewrite it first.
Oh,
Rewrite
no,
it
it's
as
not
cosine
square.
x, and then
Is
1
there-
plus sine x to the 1/2.
What if
Put
we
it on like the radical sitting there.
Okay. I will let you do that.
Okay.
Okay. What are you telling us? We still have a composition of a function
Yeah.
times another function. Which means
Substitute.
you, what do we want it to be?
1 plus sine x.
1 plus sine of x. Du would be cosine of x dx.
We have that.
We have cosine of x dx.
Yeah.
So our new integral becomes du times,
Square root of u.
U to the 1/2.
to make Jared happy, we're gonna write it as u to the 1/2. Is everyone okay with that? Alright. So when we integrate u to the 1/2, we get okay, increase the power, divide by the power, plus c.
And plug in the 1 plus sine
Please do not forget to go back and substitute x back in for u. And voila.
That one was much easier.
But that one looked hard, didn't it?
Nah, no, that
If
was-
you just quickly glance at the screen, that one looked scary, but it wasn't. Right?
And the other one,
Looked easy and it wasn't. Okay, let's do another one.
Oh,
I think-
I got one. I got one. Let's
Kelly,
do-
come pick it.
Yeah.
do that one. Do that one.
It does not look fun. Do mine.
Okay? So, can it be rewritten for a power rule? Do we need to do substitution? Can we just do it as is?
Well,
As is.
Rewrite it.
We can use substitution. And Kelly, what would we substitute u for?
The 1 plus x.
Which means du is
4x.
4x cubed dx. What I want you to notice is that what is inside the function is polynomial. What's outside the function is 1 degree less. Okay, that is set up perfectly for substitution. Because when you use your substitution and take that derivative, you have what's outside.
We just have to make it divide by 4.
Okay, now we have x cubed dx, which means we would need to divide that 1/4 over, right? So we're gonna make this substitution, excuse me. So we have 1/4 du, right? Times 1 over the square root of u. What do we need to do with 1 over the square root of u before we integrate?
We usually
We need to rewrite it as u to the negative 1/2. So now when we integrate, we still have this 1/4. U to the negative 1/2 becomes u to the 1/2, and then we have to divide by 1/2 plus b.
So it's
So one half u to the 1/2 plus c.
But what was u?
1 plus x to the 4.
Now, if you left it as 1 plus x to the 4th, the quantity to the 1/2, that would be fine. Just realize on a multiple choice, they would switch it back to the radical. If you left it to the 1/2 power, that's fine. Questions? Okay, let's do a couple more. I'm going to choose this one. Didn't we do? What? I'm not going to choose that one. For some reason, it's not working. But did we do one similar to this?
No.
We did just cosine and sine switched, right? Okay.
We should still do
I don't
it.
understand.
Something like something.
Wait, that one's different because only sine or only cosine is squared.
Right. Instead of sine being squared, cosine is squared.
So we should do
Yay, I got it. There are two different ways we can do this one. When you look at it, what do you see? Rewriting it. We could rewrite this to sine over cosine is times 1 over cosine is okay. That's a lot quicker than substitution, isn't it? Okay, so if you can see that, probably the better way to go. But if you can get there with substitution and get to the same place, that's fine. All right. You want to choose one? Like there's one that you want to choose.
Yes.
Tangent theta, secant theta.
Secant u is the inside, or secant theta is the inside, it's u squared and go to u squared.
Okay, so we still have a function, we still have a composition times a function, because we have secant inside of our x squared function,
Yeah.
right? So, can we let u be our secant theta, because it is the inside function?
Yes.
That means du would be secant theta tangent theta d theta. What? Well, okay. I'm gonna rewrite this is tangent theta secant theta secant theta d theta. Right? I just broke that up. We have tangent secant d theta. And that gets replaced with what? Du. Left over is secant, which is u. Right? Okay. So then when we integrate, we get 1/2 u squared, which becomes 1/2 secant squared. Kind of a nifty substitution, right? Okay. I want to do one more of these. There is one that I've been waiting for you to pick.
Is it that one?
It's this one.
No.
gonna be the cotangent.
There's no, you don't know what you're writing.
Oh,
Thanks.
now let's do it.
Oh, that makes everything so much
There's
clearer.
1.5, rewrite it,
Yeah.
Rewrite it to 1/2
x to the negative 1.
x to the negative 1/2. Simple power rule, right, people?
Looks like there's twisted, sounds like.
No.
No.
No, I would
Power
say-
rule. Like simple power rule.
I don't want you guys to be freaked out by simple problems, okay? You can't be blinded by
I
the
know,
power
that
rule.
cotangent one scarred me.
Okay? So now what? When we integrate, we get x to the
1.5
1/2.
times 2.
Times 2.
Oh my gosh,
X
it's
to the 1/2.
square root of x plus 2. Oh my gosh.
Nice, right?
Yeah.
Uh-huh.
I hope that that's it. I hope that's not what it's tomorrow. Or on Tuesday.
I picked the easiest one. Nah.
I didn't look like it.
Don't judge a book by its cover.
I think we're
Okay.
all upset about this.
Let's throw in some more functions to the mix.
Oh, we have to put something to a power of a tangent function. There's not a single number in there.
Do not panic. Have we had any number really?
Yes. We just did one.
Okay, we just had a few.
Makes
Fair
me feel a
enough.
little better. There's
Okay.
no numbers.
What do we
E is the
have?
number, Aaron.
We have sine of x times e raised to the cosine of x. Do we have a composition times a function?
Yes, you do.
Yes. What is inside of a function?
Cosine of x.
Cosine is inside our e to a power, which means, look how nifty this is, we can let u be the cosine of x, which means du is,
Negative sine of x.
thank you, negative sine of x dx.
The right train is just.
We have sine of x dx.
Okay.
So yes, we're going to have negative e to the u du.
You do.
Now says.
So it's just e negative.
It's just e to the.
So when we integrate, negative e to the u is e to the u. And so we rewrite it as e to the cosine of x. Yep.
Do it.
Okay.
That's what I said.
You'll admit when you say
What I need you to be able to recognize in this problem is that our inner function is cosine and what's outside of the function is sine.
Sine.
We know that those have a derivative relationship, right?
They do.
You need to be able to notice that and say, substitution, perfect.
Probably getting ahead of ourselves, but what's the application of anti-groups?
Oh, we have so much to talk about next semester.
Jared, don't ask that.
We're gonna spend about 2 weeks talking about
Okay,
the
what's the
application.
application of e to the cosine of x?
It's a function.
Is that ever gonna come up in any career ever?
Engineering.
Math
Yeah.
teacher.
Math teacher.
Yeah.
Point proven.
Okay. Does that make you happy now?
Sure.
All right.
Like when we were
You're
doing
really getting ahead of yourself.
when we were doing
okay?
rose curves last year, I was like, what is the application of this? He was like, nothing really. I'm like, oh, okay, that makes me feel better.
Well, with those rose curves and those parametric functions, or parametric or polar functions, you have a lot of like graphic design in there that you can do with it, right?
Yeah.
Okay. So you're, until you know what an integral means, or when, like these are what we call indefinite integrals because we are, there's no numbers here. Pretty soon we're gonna have numbers here and here where we're evaluating an integral over an interval, and that is gonna have some meaning as far as
Okay.
a graph, okay? And
Fun.
other problems. It is a lot of fun, actually.
So you become a math teacher.
Hey, look, there's another one. We should find what 1 over x make that 13 inside here.
You have a what?
I'm really done myself.
Do we have a function inside of a function times another function? Okay.
That's
Oh,
what-
no.
Our composition is e to the 1 over x, right?
Yeah.
Well, notice this.
It's gonna be a long.
No, if u is 1 over x, what's du?
1 over x squared.
Negative 1 over x squared.
Okay, here is where you guys need to be careful. When you're doing u to u substitution, you have to keep straight. How do I differentiate? How do I integrate?
Oh,
A lot of
geez.
you are trying to tell me that the derivative of 1 over x is the natural log. That is false. That is the antiderivative. Okay? So you need to be very careful as you're doing this. Okay? Is everyone okay with the derivative?
Yes.
Alright. Which means, okay, oddly enough, look, we have that 1 over x squared thrown in there. So we have negative the integral of e to the u
Would
du.
you ever
Isn't
give us
that
a
the
pop
same
quiz
thing
and
that we
just to
used?
mess with us, constantly give us ones where there weren't anything on it that we could substitute and say solve through substitution? Like just
I would never say solve through substitution. I would say integrate.
Do it.
So when we integrate this, we get what?
E to the
Negative e
to the u plus c.
Negative e to the 1 over x plus c. Circle it. That's a weird.
That's a box.
My knuckle hit it.
Excuses.
That's not a
It's
circle.
still a better square than I could almost miss.
That's more of half a square.
Last question.
Rewrite
How?
u to the x over u to the x plus u. Or, no, you can't, just kidding, that's.
You cannot break up a denominator.
But there's no functions inside a function.
You don't
So
think so?
unless 1 plus e is raised to the x power, then it's x to the x. But I think e to the x is the same thing. I don't think there is.
There's not.
Oh.
She's nodding. She's nodding her head.
We have a function 1 over x, right?
Yeah.
Okay.
Oh, and 1 plus e to the x is x.
If we let u be 1 plus e to the x, what's the u?
E to the x.
e to the x dx, which we have
Crazy.
right there. So we could rewrite our integral as 1 over u du.
So can we do that with anything with a denominator? Technically?
No, because it has to, whatever you put for your u, when you take the derivative, it has to be an
Well, I mean, like,
integral.
if it, so, okay, yeah.
Okay. So when we integrate 1 over u,
That's all for you.
you get the natural log of the absolute value of u
And
plus
plus
c.
And then u is e to the x. Or 1 plus e to the x. That's
Now.
the value.
Can 1 plus e to the x ever be negative?
No.
E to the x is a positive function, and we're adding 1 to it. So if you don't have the absolute value there, it is not wrong, because that will always be positive. So it's not necessary.
But you do need that.
So if we left the absolute value,
It would be fine. No, it would be fine. It's just redundant. That's my point. Okay? There are times when you need the absolute values. There's times like this that it's not necessary, but okay. Alright? Let me go ahead and stop this here.